What's the worst technique you could use to solve this integral?
Looking at this integral, the easiest way is probably a u sub, right? We have the derivative of one of these two in the problem. A u sub could handle this pretty easy, but I want to do it the worst way. So I'm thinking integration by parts. With integration by parts, we need to decide what our u is and what our dv is, and then get our resulting terms. So let's do this. Our u, let's go ahead and make sine of x. Our dv, let's go ahead and make cosine of x dx. If we integrate this, we would get sine for our v. If we differentiate sine, we would get cosine x dx for our du. Okay, I went ahead and plugged in for our formula. Remember, integration by parts is integral u dv equals uv minus integral v du. When we look at this, we should notice right here, we have the same integral that we started with, right? So we have a copy on the right side that we have on the left. What if I just took this and I moved it over here, right? I'm going to go ahead and add that term over. Well, we should end up with twice our starting integral. And what would that equal? Well, that would be this expression, which is simply sine squared, plus, of course, some constant c, right? We were integrating. This integral would have contributed some other constant on this side, but since we moved it over, I need to take care of that plus c. Our final step, of course, is to move the 2 over. You didn't want to find integral of 2 times that thing. You just wanted the integral of sine cosine. So therefore, our final answer, sine of x cosine of x, would equal 1/2 sine squared of x plus c. There we go. That would be our final answer.
Okay, maybe not our best technique, but it got us there.